This is part of a series of demonstration videos to review how openstack-helm works. openstack-helm is an open source project that aims to provide a fully self-contained Helm-based OpenStack deployment on top of Kubernetes. In this particular video, I'm going to demonstrate the upcoming openstack-helm container build pipeline and demonstrate making a change to an OpenStack Git repository housing my organization's custom keystone code, and then releasing that as a brand new container using the openstack-helm framework with a hitless upgrade. So, in other words, the scenario is, as an organization, I maintain my own Git repositories with the OpenStack code, and of course I have teams developing upon those, and they want to go ahead and make changes, build containers around them, and then release them to Openstack-helm environments. The Openstack-helm container build pipeline that I'm going to refer to is something that's still under development today and is not out in the community just yet, but this gives you an idea of where we're going and really the full stack that we intend to release with Openstack-helm, from bare metal provisioning all the way until a working CI/CD pipeline for organizations to absorb and adapt. So the very first thing that I'm going to do is go ahead and check out my organization's keystone repository, which for the purposes of this demo is really just a forked copy of the OpenStack keystone repository. On the right-hand side, we see all of the containers that were deployed as part of an Openstack-helm deployment. Of course, the Keystone API is part of that deployment and is already running in this environment. We are going to essentially take that running and working version of Keystone and do a Helm upgrade on that with a new image, and that should go through a Kubernetes rolling update process, and of course the API service for Keystone should not fail to serve any end user requests while we go through this release process. So the first thing that we want to do is we want to base our change on the Newton release. So we are going to check out the 10.0.0 tag. We're going to switch to a new feature development branch. My feature is going to be very simplistic. I just want to add one line to the Keystone code. We are just going to add a new log line. And save our change. We are then going to commit our change. And then finally, we're going to push our change back to my organization's Keystone repository. So the last thing that we're going to do is grab the very latest git commit from our change, now that that's been pushed upstream. And then we're going to go to our Openstack-helm build process. And we're going to run a new build based on that specific git commit. So our pipeline consists of a kolla build container. Uh, Essentially, what happens is that Jenkins launches a Docker based kolla-build container, uses the information that we provide here, feeds that into the container, and allows a kolla-build process that's completely containerized to build a brand new kolla-based container based on a specific git commit from um, our own organization's repository. So the only thing that we really need to change in this build is we will give this brand new container a tag. Um, we'll just make one up. We're going to use a specific git commit, and all the other values, because this is a Newton-based image, can stay the same, and we can go ahead and launch that build. Now, the build traditionally takes about 30 minutes, and so we don't really want to wait that long. So we have another image that's already been built that has essentially the same change, and we are going to go ahead and launch the release process, which essentially is an openstack-helm upgrade specifying a new image that contains our code change. So on the right-hand side, we should start to see the Keystone API containers being terminated. We will start a polling process while that's happening. Before we actually do the release process, we want to go ahead and make sure we start something that can go ahead and pull the Keystone API so we can validate that this is indeed a hitless rolling update, and of course we can release our minor code change without actually impacting the Keystone API service. So we're just going to launch that and let that go ahead and run in the background, and then we can go ahead and do a release of our pre-baked Keystone image that has our change that's already gone through the pipeline. So what we see happening here on the right-hand side is that essentially our old Keystone API containers are being replaced. Obviously, one is still running because of our rolling update parameters. That's allowing our Keystone requests to be served, while the new containers with the new image that contains our code change are being spawned. As soon as those become actually ready and they start passing readiness tests, then the previous original containers with the old code are finally completely retired. So that took about 45 seconds to do our release of our new container image. And what we want to do now is use a utility called weave scope. We could do this on the command line, but this provides a nice way to do visualization. We will go ahead and actually hop into one of these containers and just validate that our code change is actually there. This container has been up for about 50 seconds. So if you recall, we actually changed the Keystone common WSGI file. And the line that we added was a simple log line that is now present in the container. And obviously down here we were able to poll the Keystone API service the whole time that we did our Helm upgrade process, and we did not lose the capability of querying the Keystone API while releasing our new container.